Yeah, please. Okay, now I'm going to move off this method, but not quite. Okay. Part of the reason why this is so confusing, okay, is because I have 1, 2, 3 regions. There's a way to cut it down to 2. Can anyone tell me?
Higher max mode.
Where did the 3 regions come from? One region came from the absolute value, right? The other region came from the fact that I had to multiply by this x, and multiplying by x means like which way do you go and so on. Okay? So to get away from that problem, this is method 2. Okay? I'm still going to solve it by regions. Okay? But this time, I'm going to multiply by x squared. Okay, now why is multiplying by x squared a better idea than multiplying by x?
Because you know it's positive.
X squared is always positive, so I don't need to worry about which direction the inequality goes. I just have to worry about this absolute value. Okay? But it lends its own problems. Okay, so I'm going to get rid of all of this. How can we make cases better? Right? So when you multiply through by x squared, what happens? You're going to get an x on this side, right? Because x squared times x, yes. That absolute value is still there. And then you're going to get an x on the other side. Sorry, an x squared. Now, here's why multiplying by x squared is both better and worse. It's better because now I don't have to worry about the direction of my inequality. But it's worse because now I've got to solve a quadratic. Okay? But it's not that bad at quadratic. So let's go ahead. In order to actually expand this out, then I have to introduce cases. Because it's like, well, what kind of absolute value do I have? So, case 1. If x is less than a third, what do? What happens to the absolute value?
It becomes a minus.
I've got to slap a minus sign on it, right? So I'm going to get this. Okay? So now do your other case. By the way, the reason why I always set up all my cases first, okay, is because then I can think, oh, okay, the difference between this case and this case is clear in my mind, rather than do this case, solve it, and then, okay, now what was my other case? What was I doing? I can't remember. Oh, there's a butterfly. Okay, so don't be distracted. Do your cases all the way. Okay. There may be. I make no guarantees about the presence or absence of butterflies.
That's just very strange.
All right, if x is greater than a third.
Postmodernist.
Sorry. Okay. This means there's no negative on the front, so I'll get this. Okay, now I've set up my cases. Let's solve them. Okay, it does tend to turn out to be quite simple. All right. So here I've got minus 3x squared plus x less than 2x squared. Okay. So let's see here. Subtract 2x squared. So x minus 5x squared. So that's x outside of 1 minus 5x. Is that okay? Yes? Now what does this guy look like? This is a parabola. Is it concave up or down?
Just a frown.
It's concave down, right? So the roots are 0 and a fifth. That sounds familiar, doesn't it? Okay, so that's what I've got. 0, a fifth. Now I want it to be less than 0. Yes? So this part's okay, and this part's okay, and this part in the middle is busted. Okay, but I got to combine my conclusion with my case, right? So x is less than a third. A third's somewhere over here, right? A third. Okay. So that means, what have I concluded out of this? I've run out of space. Okay. Okay. What this leads to is x is less than 0, or between a fifth and a third. Does that make sense? Can you see how I've gotten that out of there? Question?
You know, what if you move the negative 3x squared to the other side, so it's 5x squared minus x instead of x minus 5x?
So you get the same thing? You
But the parabola is different.
No, it won't.
The problem, Richard, the problem will be different, but then the sign.
No, it won't. It won't. It's the same one. Trust me. If you start in this case, unless you screw up the algebra, it's the same case. Okay. Yeah. Trust me.
Why?
Go home and do it, and you'll see you've got algebra problems. I'm serious.
And of course, it will say it's greater than 0.
I'm moving on.
He's saying he did it and he got a different problem.
Yeah, in that case,
Why?
I'm moving on.
It's a different parabola, but you find the same.
Okay, this case here, 3x squared minus x less than 2x squared. Okay, take the x squared over. So I'm going to get x squared minus x less than 0. So I've got x outside of x minus 1. Again, this is a parabola, but it's concave up, right? And its roots are at 0 and 1. Now, I want the parts that are less than 0. Yes? So that's these parts under here, 0 and 1. But I have to include my case and my conclusion together, right? So I want to be greater than a third. Where's a third on this? It's like there, right? So now I've ruled out that part because it's not greater than a third anymore. So from case 2, what I've got is I'm between a third and 1, right? Which takes me back to where I got from my first method, okay? X is less than 0, that's fine, okay? A fifth to a third, test x equals a third, and you verify it, and then a third to 1, okay? So I'm back there, I'm done.
But do you need to test the end bits or just the connecting point?
The reason why I do not need to test a fifth or 1 is because the way I arrived at those numbers was by algebra. But I have to test a third because I've arbitrarily taken out a third as a valid answer. Because look, I didn't even test it. I'm less than a third, or I'm greater than a third, and I just forgot about a third, okay? To make my cases unambiguous, right?